Hi everybody, this is Mr. Folly and welcome to the last part of the last lecture for 7 for equilibrium. And let's just go ahead and get started. Define the following term, solubility of product. It would be KSP, which is the product or the answer. Come on, eraser. Answer to the multiplication of ions raised to their coefficients. Solubility is typically the mass dissolved in a certain volume of solution. Now that's going to be volume of solution, not volume of solvent. So just be aware of that. Give the dissociation reaction. Give the dissociation reaction, then determine the solubility and moles per liter of each of the following, given KSP. So let's go ahead and make this. Oh, that's weird. That's the wrong one. So dissociation reactant is AgCl. Turns into Ag positive plus Cl negative. Okay. And that gives us the KSP. So I have sum 0, 0, minus x plus x plus x. Notice that my coefficients are 1, so it doesn't really do much. I don't care, x and x. KSP equals Ag positive times Cl negative. So that's 1.8 e negative 10 equals x squared. Okay. Now notice the show x squared shortcut. So whenever I have two subscripts, right, that's going to be x times x, 1x times 1x raised to the coefficient of 1. So when I do this, 1.8 e negative 1.8 e negative 10, I get, I need to square root that, second answer, because that's typed in there, and x equals 1.34 e negative 5, and I always label what that is. That's molar, and that's molar solubility. And it also equals Ag positive, and it also equals Cl negative. Okay, let's do the next one. Got another one. See how it's 1 and 1, so it's just going to be x squared. So it's multiple choice. You can do that shortcut I showed you before. I'll show it again. AgBr is in equilibrium with Ag positive plus Br negative, no coefficients. Sum 0, 0, minus x plus x plus x. So initially I have sum, change, and at equilibrium. If I don't care, x and x. KSP is ions Ag positive, first power, Br negative, first power, x squared equals 5 e negative 13. To estimate squareds, remember you're just going to divide this by 2. So I should have an exponent of negative 6.5 if such a thing existed, but you get the idea. Second root, 5 e negative 13, and I have 7.07 e negative 7. That's not x squared, that's x. Molar, which is molar solubility. It also equals Ag positive. If you put it in brackets, that means molarity, which also equals bromide negative. So for this one, you see I'm going to have, right away I should be able to tell in my ice diagram, I'm going to have 2x and x. So my KSP is going to be 2x raised to the coefficient squared times x. So KSP, so this would be 1.1 e negative 12 equals 4x squared, 4x to the third. Right, so 2x squared, 2 squared 4, x squared times x is 4x cubed. I'm going to show you in a second the work that got me that. So 1.1 e negative 12 divided by 4 And then remember, I cube root by raising it to the quantity 1/3. And I get 6.50 E negative 5 equals molar solubility. And that's going to equal chromate 2. So let me show this. Ag2CrO4 is in equilibrium with Ag positive plus CrO4 negative 2. But notice I got a 2 here. Sum 0, 0 minus x minus 2x. I'm sorry, that's plus 2x plus x. I don't care. 2x and x. So see how you can kind of see that coming from this? You get better at it. So then when you write KSP, it's going to be 2x squared from this, and x from the fact you got one of these. And then you do the math. PbCrO4, so do you see how I have one lead and one chromate? One lead and one chromate means I'm going to be KSP equals x squared, right? And I can do that right away. So you will see these as multiple choice questions. I don't know why I'm doing the order a little different in this one, but that's okay. Sum 0, 0 minus x plus x plus x. I don't care, x and x. So KSP would be chromate. If it's a free response question, it'll ask you for each of these parts. It'll say, write the dissolving equation, write the KSP, solve for the KSP. And here we're going to have, solve for the molar solubility. 2.8 E negative 13 equals x squared. X equals 2.8 E negative 13. I guess I got to square root that. I'm already in a bad spot, so I'm going to raise that to the 1/2. And I get 5.29 E negative 7 molar equals molar solubility. And it also equals Pb plus 2. And it also equals chromate minus 2. Now, I know I'm going through these really fast, but we want to get these to where they're annoying instead of hard. So, another one. How about another color? I like a darker color. So notice here we've got a different deal here. Uh-oh. Okay. So we got a different deal here now. So notice how this is going to be x times 3x cubed. So that's going to be 27x to the 4th is what we're going to get. So CrOH taken 3 times is in equilibrium with chromium plus 3 hydroxides. Sum 0, 0 minus x plus 3x. I really don't care. X and 3x. KSP equals chromium plus 3 times hydroxide cubed. So chromium is x, hydroxide is 3x quantity cubed. Do that math, and this was 1.6 E negative 30 equals 27x to the 4th. And then I do the math. 1.6 E negative 30 divided by 27. And then I've got to 4th root that, raised to the quantity 1/4. My molar solubility is 1.56 E negative 8 molar equals molar solubility equals chromium plus 3. All right. Give the solubility of the anion. So the anion is the negative ion. So let me just give the solubility form. I'll highlight it in yellow because I think I did most of them. Anion is the negative ion. So Br negative was X, so it was the same as the anion. This was X, same as molar solubility. This is X, same as molar solubility. This one is 3x, so I've got to do, here's what I got to do differently. So 3 times 1.56 e negative 8 is 1.56 e negative 8 times 3, which is 4.68 e negative 8 molar. So 4.68 e negative 8 all the way down here. There you go. How would the solubility of number 28 change if it were in 50 milliliters of total solutions? Okay, so get the solubility of the anion. So how would the solubility change? It wouldn't. Solubility is moles per liter. So if we did it, so if I did moles over 0.050 liters, notice how that would be 50 milliliters, what would happen is, in order to make this divided by 0.05, I would have to multiply by 0.05, right? So I multiplied the bottom by 0.05, so I'd have to multiply the top by 0.05 as well. What condition must be true to directly compare KSP values to determine relative solubilities? Same, whoops, I'm going to erase that and try it again. Same subscripts. So you can do a direct compare of AgCl to NaF, but you can't do a direct compare of AgCl to Na2S because this would have different X values. Circle the more soluble salt based on KSP. So this is going to be X squared, and this one is going to be X squared, so they're the same. So more soluble salt, so I want the bigger KSP. So my bigger KSP would be AgCl. Okay, so on this one, I'm going to have 2x squared x, or x cubed. And over here on this one, I'm going to have x times 2x squared, whoops, times 2x quantity squared. So those are the same. So I still want the one with the bigger KSP. CaF2 versus Ag2S, this is another one where I'm going to have x times 2x quantity squared. And over here, I'm going to have 2x quantity squared times x. They're still the same. Just going to pick the one with the bigger KSP. Okay. 32. A 1 liter saturated solution of calcium oxalate contains that many grams of calcium oxalate. Write the dissociation reaction. Include phase symbols. So CaC2O4. That includes phase symbols. I often don't. It's going to give me the ion Ca plus 2 plus C2O4 negative 2. And that's balanced. Calculate the solubility of product constant KSP. So I know this is my grams in 1 liter. So what I'm going to do first is convert that into moles. So moles equals MV, but first I got to convert this dog into moles. So 0.0061 grams of CaC2O4 times grams CaC2O4. 1 mole CaC2O4 equals, okay, calculator time. Calcium is 40.06 plus 24.02 for 2 carbons plus 64 for 4 oxygens, 128.08. That doesn't sound right. So 4 times 16 plus 24.02 plus 40.08. Good enough. Okay, so that is it. So 0.0061 divided by 128.08 is 4.76 E negative 5 molar. Okay, so I got that in molarity now. And remember, that's what minus X is. Okay, so this is going to be my minus X because that's molar solubility. So CaC2O4 is in equilibrium with Ca plus 2 plus C2O4 negative 2. So I have sum 0, 0. I know my molar solubility is 4.76 E negative 5. So I'm going to lose that much there. I'm going to gain that much here. I'm going to gain that same amount because I don't have any coefficients. I have coefficients of 1, but get the idea. I still don't care about you. 4.76 E negative 5. 4.76 E negative 5. My KSP is calcium plus 2 times C2O4 negative 2. So it's going to be 4.76. Oh, man. My pen went too fast. 4.76 E negative 5 squared. So second squared, my answer I got in there. I got quit go to. So let's see what we got here. Oop, I square rooted it. That's why. 4.76 E negative 5 squared. I have 2.27 E negative 9. That's it. Solubility of fluoride in a saturated solution is this much. Write the dissociation reaction of strontium fluoride, including phase symbols. So I'm going to cheat a little bit. I'm going to do it over here. SrF2 solid is in equilibrium with Sr plus 2 plus 2F minus. And it's going to say determine the molar solubility. So the solubility of SrF2 is this. Determine the molar solubility of it. We just did 1.76. The solubility of fluoride. We didn't. So this is sum, 0, 0, minus x plus 2x. This is solubility. This should say molarity. I apologize. And this is I don't care. And we know that this, for fluoride, is 1.76 E negative 3. So this is going to be half as much, right? So I'm going to take that number, 1.76 E negative 3 divided by 2. I'm going to 8.8 E negative 4. And determine the molar solubility, that's x, right? So that equals x, which equals that, 8.8 E negative 4. I'm going to put my 3 sig figs on it because you know I love those. 8.80 E negative 4 molar. Determine the KSP. KSP is strontium plus 2 times fluoride squared. So my strontium is 8.8 E negative 4. And fluoride is 1.76 E negative 3 squared. So let's do that. So 1.76 E negative 3 squared times the answer I had before. And my KSP is 2.73 E negative 9 equals KSP. All right. If 0.0490 grams of AgIO3 dissolves per liter of solution, calculate KSP. So this one's hard because we don't use iodate a whole lot. Here's my dissolving equation for it. It's +1 and iodate is IO3 negative. That many grams dissolves per liter, so I got to change that into moles. 0.0490 grams AgIO3 times 1 mole over, go to the periodic table of AgIO3. Whoops. Silver is 107.9 plus iodine 126.9 plus 48 is 282.8. So 0.0490 divided by 282.8 is 1.73 E negative 4 molar. Okay, so that's going to be minus X. That's my molar solubility. That's going to be minus X. Sum 0, 0 minus 1.73 E negative 4 plus 1.73 E negative 4 plus 1.73 E negative 4. In the end, I don't care. Same thing. So my KSP is going to be Ag positive, IO3 negative, 1.73 E negative 4 squared, which would be, answer squared, 3.00 E8. And I'll stop this one right here so I can render it and put it up and post it and send the next batch a little later. So, toodles.